Hi, my name is Matthew. I'm a student at the University of Glasgow in undergrad, and I'm going to be talking about Cenerate, which is a 2D sign language agent. Just to let you know, I'm going to be signing throughout this presentation just to give you a wee bit of an idea of what it's like sign language, and specifically I'm doing BSL, so British Sign Language. So why do we want to look at sign language conversational agents? Well, there's a lot of deaf people around the world, and they always face problems every day because of communication barriers. And we already have translation and conversational agents for spoken languages like English. And we were trying to think, well, what work is there in sign language conversational agents? So we just decided to explore the problem of making sign language. So going from English to sign language, so making the animations. The previous work we looked at, there was Tessa quite a long time ago that was working in the post office, and it was very limited vocab. There was also How to Sign, which was a sign language data set in ASL. And there was also Text to Sign, which was going from text to sign language. And it's a lot, quite similar to what we're doing here. But we find that there's a problem that's common to all of these, which is they use technologies that aren't very available, let's say. So with Tessa and How to Sign, they use motion capture and depth cameras, and they use that to build up their data set so they know how to make the motion and the sign language animations. But to make a data set for a full language using technology that's you can only record in one environment would take a lot of effort and time. And with text to sign, it uses a lot of GPU resources, and that's because it's using neural networks to make the animations. And if you want people to have a sign language conversational agent in real life and everyday life, then you can't expect people to carry around a lot of GPUs in their backpack. So we decided to make our own one to see what we could do. And we had requirements that we were trying to achieve. The first one is that it was comprehensible, so understood by sign language speakers. The second is it's got to be general. So we want this to apply to any sign language. So not just BSL or ASL, just anything. And that way it'll be more portable. And it's got to do this from learning from examples. The third thing is lightweight. So again, it needs to be able to be run on conventional hardware, like a laptop or a phone. And the last thing is it's got to be versatile or flexible. So it's got to be able to sign everything. So what did we do? So first of all, we got some video examples to make our own small data set. Then we were making a pose dictionary. And then from this pose dictionary, we were animating the agent with the poses. So going a wee bit deeper, here's an example of one of the videos, and it's just me signing the letter A. In our data set, we only have a British Sign Language, and it's only the alphabet. This is because we just wanted to focus on something smaller just now, so we can upscale it for later. But this work can easily be made to fit to a more full vocabulary, like words and full sign languages. It's also got 8 sets of videos, and it's mostly of me, but there are some videos from signbsl.com, which is a good website to look at to see there's already a lot of video examples of sign language, and they're labeled with what they're translating. So now making the pose sequence dictionary,
Matthew, just excuse me, did you intend to show a video? Because I couldn't see a video, it was just black. And the
Okay.
play button was seen, but that was it.
Do you see it now?
Now it's there, yeah? Perfect. Yeah.
Okay, yeah. Okay, hopefully the other one works. Okay, so we're using OpenPose, which is a well-known pose estimator. It's very fast and very accurate as well. But we only had videos, right? So it's only one camera perspective. So OpenPose doesn't get a 3D poses from 2D video. So it meant we only had 2D poses, and that means we only had a 2D agent. Now, of course, a 3D agent would be much, much better for comprehensibility, but we found that there's not a lot of good options for 3D pose estimation from video. There is one called Human Mesh Recovery, but it's only working on images just now. And we were just thinking that, you know, humans, we already understand 2D animation and convert it to 3D motion in our heads. So we think humans do better at this than anything we can do on computers for now. So now the animating of the agent. So on the right, you can see a picture of the agent, and you can see a comparison here of the poses. The agent is made of individual body parts, and when they come together, they make a pose. So we just take our OpenPose data from the dictionary, and we assign the data to each body part to get the position, rotation, and scale. And we use Piglet to do the actual animation itself, which is just a game engine. So hopefully you can see the video here, the example. And here we are. So it's just signing hello world here, but using the alphabet, obviously. So I'll just give a comparison of me signing this as well. So there's an O here, and we're going to do W, O, R, L, and D. So quite simple. So then we moved on to our comprehensibility evaluation. So we had 10 phrases, and they used a lot of variety of letters. You can see the phrases in the bottom right here. We had the two agents, so the human and the virtual agent, which we made. And the virtual agent is based its examples. It's based on example videos from the same human who was signing in this comprehensibility evaluation. Then for every user, we split the 10 phrases to 5 and 5 for each agent. And then the user wrote down what they thought the agent signed. So moving on, we had 11 users in total. So it's not a very big user base, but there's not a lot of people who know BSL. We took all the things, all the phrases that the users wrote down, and we got the string distance to what the agent said. We normalized it and then got an average for every user. And you can see that the human agent was understood much, much better than the virtual agent. But you can definitely see also that the virtual agent didn't fail completely, wasn't far off the human, and was understood very well by users 6 and 9 who understood it the majority of the time. We also wanted to see if experience had any impact, and we found that it didn't, no matter if they were an expert in BSL with 10 plus years or less than 1 year. We also got some user feedback through this. They said sometimes it was a wee bit difficult to find distinguish the different signs. So like the vowels, A, E, I, O, U. And also they said it was hard to know what body part is on top of another. And this is definitely a weakness in our agent because it has a fixed drawing order. So it means like the hand is always drawn on top of the body. And this sort of fails our versatile requirement. So just the conclusion, was it general? Yeah, so we can apply this to any sign language, so different sign language alphabet, and the animation software can be changed to use words, look for words and not letters. Was it lightweight? Yeah, just worked on a normal laptop, no special GPU or anything else, it's just video. And was it comprehensible? Somewhat. Again, not the same as a human, but it's still not understood at all. And lastly, is it versatile? No, we need to change this to a flexible drawing order. So further work that we might have is maybe more differences in the body parts, more features to help tell similar body parts from each other. Maybe helps with the A-E-I-O-U similarities. The flexible drawing order, we also thought maybe of trying to make an average pose sequence. So if we have multiple videos of the same sign, trying to get an average pose sequence that's more general. And lastly, of course, moving to a bigger data set, like a full sign language with words or different sign languages. And thank you for listening.